So that latter problem we have seen, where we have discussed. So analysis of pin joint frames. Analysis of pin joint frame. So once again, I will ask: is it necessary to repeat that problem? If yes, immediately I will repeat. If not, we will go to the third chapter. What to do? What to do? Shall we go? Hello? Hello?
Yes, sir.
Yes, sir.
What? What yes? Miss, shall we continue or I have to repeat that?
Continue, sir.
Okay. Those who have not understood, they can contact personally. We will discuss. Those who have understood, it is well and good. I hope everybody has understood, because there was, we can say, problems we have solved where there was a free body diagram, and on which number of forces were acting. There were total three unknowns, three equations we can solve. So we have solved that problem. Okay. So unit number 3, analysis of pin joint frame. So hereafter, this will be the last chapter from the section number 1, or from the statics, where prerequisite. Prerequisite means what? Prerequisite means basics. Prerequisites are required from chapter number 1 and 2. Means here, whatever we have studied right now, resolution of force, calculation of moment, etc. It is first step here. In these problems, calculation of all that things will be the first step in all such problems. Okay. Means it is primary step to calculate the force, to calculate the forces in the member, etc. So let us go for the syllabus. What it is there in the syllabus? So analysis of pin joint frame. Can someone tell me what do you understand by analysis? Analysis. Have you come across this word, analysis? Something we have to analyze. What does it mean?
Survey.
So we will discuss today. Be relaxed, be talkative, be interactive. Padtalne, very good. Again, judgment, again. Very good. Again, what we can say? Anything else? Analysis. What does it mean by analysis?
Recognize.
What? Be talkative, be interactive. If you are, we should not expect our answer should be correct. You should expect I should give answer in that way. You should
Vislation.
give the answer. What?
Vislation.
Okay, vislation. Okay, analysis means okay. Okay, good. Those who have given answer, it is good. Analysis means something, judgment, etc. But in our case, analysis means to find forces, to find forces, to find forces. Actually, same word. Once you are going to go in further subjects, maybe in strength of material mechanics, in that way. So there it will be having meaning to find the stresses. Stress means what? Stress. Have you heard of this word? Be relaxed. We are going to discuss different things as a basics. Have you heard this word stress?
Yes, sir.
Yes, sir.
What does it stress?
Pressure.
Tension.
Okay.
Tension
Pressure.
force.
Okay. Again. Again. Anything else? Good. At least you are participating. It's good look. So pressure, stress, and this stress and pressure. What is the unit of pressure? You might be knowing. Force per unit area is called pressure. Even stress is also same. F by A. F upon A. A is area. F is force. So F upon A is either stress or pressure. It is either stress or either it is pressure. So what does it? So unit of both is same. Unit of both it is same. But stress and pressure, whatever you have given definition, it is correct. But there is major difference between this stress and pressure. Once we are going to apply externally force on the body, look at what I am telling. When we are applying force on the body externally, that condition is called as pressure. That is nothing but force upon area. Okay. On the other hand, stress is what? It is also force upon area, but it is generated within the body, or it is, we can say, opposite within the body. In short, stress is internal property of body. Stress is internal property of the body, and this one is external property of body. Means pressure means what? Externally applied force. Externally applied force. And what is stress? Internally opposition force or internally opposite force. That is stress. Unit of both is same. ज्यावेळी आपण एखाद्या ऑब्जेक्ट वरती, once we are going to apply force on the body, that body will, simple as this we can say. What is that? Once we are going to apply force, body will oppose. So that opposition is called as stress. On the other hand, what the force we are going to apply is called pressure. But analysis, we were discussing analysis. What is analysis? To find forces or stresses in the body. In the body is called as analysis. So in one of the lecture, I have given example of postmortem. So you know it is actually medical term postmortem, to finalize or to analyze, we can say, why death happened. Reason. There we were investigating reason of death. But here we are going to find, suppose we want to find the forces or stresses in the member, that is called as analysis. Further, pin joint frames. So at the discussion of this first lecture, maybe of this subject, I have given example where these pin joint frames are used, or frames are used. Frame. What do you understand by this word frame? Frame म्हणजे काय? Frame. Collection of members. You might be observing window without a glass, whatever that inside, we can say window is there, something like this, maybe something like this window. Okay, here we can say different members are connected in this way. Okay, maybe in between some members. So these members, that is one example. It is something like frame. Even I have given one of the example. Just see, are you remembering this or not? I don't know. Maybe electrical pole, which is passing here some wires in this way. Okay, and here there is a structure, something like this. Okay, maybe in this way, and different frames are there. So I have asked on that day why these members are added in between. What was the reason? Why the different members are added in between? What? Are you aware about why the different members are added in between?
To make strong.
To make strong. Okay, that may be the reason. But what is other?
फोर्स डिस्ट्रीब्यूट करण्यासाठी.
Yes, force distribute. Again, force distribution. Otherwise, what will happen if there is only single pole? Suppose there is only single pole is there. So what will happen? There is only single pole. What will happen? Suppose electrical wires are there in this way, and there is only single pole here. Only single pole, something like this. What will happen then? It may get bend or break, we can say. Bend or break. because only one member is going to take the force. Only one member is going to take force. Either it will bend or it will break. Okay, so distribution of force is required. So it is as simple as this. Okay, force distribution. So analysis means to find the forces in pin joint pin frame. Okay, so let us go further. Just introduction of this chapter we will see today. You can ask in between question whatever you want to ask. Okay, this is our bonus lecture we can say. So syllabus, pin joint statistically determinate, plain truss, plain trusses, perfect frames, assumptions, determination of nature and magnitude of force in member, simple trusses, zero force member, analysis of truss by method of joint and method of section and a graphical method. So here, one important term we are going to see, that is truss. That is truss. One most important term we are going to see in this chapter, that is truss. Okay, so I will tell you in short what is that. So truss, this one will be most important challenging term, and we are going to analyze that truss. Analyze that truss means what? Collection of member, collection of members. Okay, that is truss in simple words. Collection of members is nothing but truss. While different members are collected together to transfer the force, or we can say to distribute and transfer. To distribute and to transfer. Two important things, which are they? Distribute. Distribute and transfer. Distribute and transfer. These are the two important terms of the, or we can say important objective of the truss. Okay, to distribute and to transfer. And there are two methods to analyze the truss. Which are they? Method of joint, method of joints, and another one is method of sections. So in syllabus actually this graphical method is mentioned, but online still we are not decided how to take. But theoretically there are these two methods. So this is our chapter, third chapter. So in morning itself I have told. In morning itself I have told. Hereafter there will be short chapters, but concept is important. How to solve it. Okay, so with the beginning I have told, here we are going to study truss, in which we are going to analyze. Analyze means what? Just now I have told, here also I have written analyze.
To find forces.
To find forces.
To find the forces. At this stage we will call only forces. In your further classes, maybe if you are from mechanical civil background, definitely you are going to find stresses, etc. But meanwhile we are going to find forces in the member. Okay, that is analysis. So in this chapter we are going to do analysis of trusses. And how many methods are there to analyze? How many methods are there? Just now I have written on the screen. How many methods are there?
Two.
Two. Which are they? Yes, method of joints and method of sections. Method of joints and method of sections. Well, let us see now, one by one. Or we can say just discuss the syllabus. Introduction. Introduction. What is that introduction? A pin joint frame. Pin joint frame is a structure made up of slender members. Slender means lengthy. Pin connected at ends and capable of taking loads at joint. Slender means lengthy. You remember this word, length. The member which has more length as compared to its other dimensions. That is, we can say lengthy. So a pin joint frame is a structure. Pin joint frame is a structure who pin joint frame is a structure, or we can say it is a frame, is a structure made up of slender members and taking loads, or capable of taking loads at the joint. Then slender is a component for which cross-sectional dimensions quite small. Just now I have told slender is a lengthy element. Such frames are used as a roof trusses. Okay, roof trusses to support the sloping roof and as a bridge. So you might have seen bridge, or we can say in fabrication, roof truss slab is different, and this roof truss is different. So you might be observing high number of elements are used while joining the truss. So reason is very simple. What is that? To distribute and to transfer the force. Okay. A frame in which all the members lie in single plane, it is called as plane frame. Most important. If a frame in which all the members lie in single plane, it is called as plane frame. Okay, it is called as plane frame. Further, they are designed to resist. They are designed to resist the forces acting in the plane. They are designed to resist the forces acting in the plane. Okay, so here, so what the way I have told, are you observing the images? Are you able to observe images? Some
Yes,
images I
sir.
put.
Yes, sir. Yes, sir.
So this analysis is important. Analysis, being not only I will say, being an engineer, we should be able to, we can say, analyze the structure. Some basic things we should know. Being an engineering or being an engineer, future engineers or engineer, we should know these terms. What is in between? What it is called? Tripod.
Yes, sir.
Here it is a tripod. Second figure. One. We can say fabrication. What we can call to one? Number one. Number three. So let us see what it is given. If all the members of the frame do not lie in a single plane, they are called as space frame. They are called as, sorry, they are called as space frame. And before that, what we have seen? Before space frame, plane frame. Plane frame. If the members are not lying in a single plane, then we are going to call it as a space frame. Tripod transmission and observation towers. So you might have heard the term dumpy level. डम्पी लेवल हा शब्द ऐकलाय का तुम्ही बेसिक सिव्हिल इंजिनिअरिंग मध्ये अजून का नाही झाला अजून डम्पी लेवल हॅव यू हर्ड दिस वर्ड डम्पी लेवल or not? Huh?
No.
Yes or no?
No, sir.
No, sir.
Okay, no issue. It will come in your further syllabus. Definitely it will come. It is also something like this camera. Okay, actually it is used to find the distances. According to me, you can check in your civil engineering, basic civil engineering.
सर ते रोड
According to me-
कन्स्ट्रक्शन वेळी यूज कर देते का?
that only you can find once you are going to travel on the road. That's something like a camera, something like camera.
कॅमेरा सारखा असते का?
That's only the dumpy level. I think according to me, it is used for to find the distance. I don't know exactly. You can ask your basic civil engineer or teacher. Tripod stand also is one of the example of space frame. Okay, tripod stand. In this chapter, analysis of only plane frame. म्हणजे आपण बघितलं होतं बघा. In chapter number 1, which type of force system we have studied? We were limited to coplanar force system. Similarly, in this chapter, we are going to analyze only plane frame. Okay, which is built. The analysis involves the application of equilibrium conditions as a system of concurrent and non-concurrent forces. So that we will see. So just now I have told what is meaning of analysis. So in this chapter we are going to analyze plane frame. We are going to analyze plane frame. Repeating, what is meaning of plane frame? We are going to analyze. So there are two terms. I want to explanation from you. What is it mean by analyze or analysis, and what is plane frame? In this chapter, only these two things are important: analysis and plane frame. What does it?
All members of frame lie in a single plane.
Then we are going to call it as a plane frame. Very
Plane
good.
frame.
What is analysis?
To find the forces.
But where? कुठले forces? To find the forces in the members of truss. That is analysis. Actually, analysis word is again in general, but related to our chapter, its meaning is related to our chapter. Its meaning is what? To find the forces in different members. To find the forces in different members. That is analysis. That is analysis. Okay, so let us see. So, are you with me? What is called this first structure? पहिल्या structure ला काय म्हटलं जातं? What is the name of first structure? काय म्हणायचं पहिलं फर्स्ट इमेज? What is the name of image of first? Here we can say transmission system, towers. But what is the name in first? If not, okay. Types of frames. Types of frames. Let us see now next. Are you either noting down or either writing in your notebook? Actually, just a theory. It is not the problems. Types of frames. Am I audible? Nobody is giving this.
Yes, sir.
Okay.
Screenshot, sir.
Okay. Afterwards, you are going to write. Afterwards, you are going to write.
Yes, sir. Yes,
Okay.
sir.
Okay. A pin joint frame which has got just a sufficient number of members to register the loads without undergoing appreciable deformation in shape is called as perfect frame. So types of frames are three: perfect, redundant, and one more. Let me know what is that. Three are there. Perfect, redundant means number of members are not sufficient. We will see. Here somewhere it is written. Okay, we will see. It will come. So first one is perfect frame. First one is perfect frame. Okay, what is that? First type is perfect frame. Why we are going to call particular frame as a perfect frame? Because whatever may be the number of members are there in that frame or truss, so both the words are same. So it is not the case that these words are different. Either we can call it as frame or either we are calling. So either we are going to call as frame or truss. So if a particular frame or truss has got sufficient number of members, to register the loads without undergoing appreciable deformation in shape. Appreciable deformation in shape is called as perfect frame. Okay. Triangular frame. So now see the image number 1. Are you able to see image number 1?
Yes.
Okay. Which type of supports are there in image number 1 or frame number 1? I will say 1. This is
Roller and hinged.
very good. Roller and hinged. Okay. Let us see now. Triangular frame is the simplest perfect frame, and it has 3 joints and 3 members. Okay. Perfect frames with 4 and 5 joints are shown in below. So perfect. Now there is a formula. There is a formula how to decide it. How to decide it. Okay. So what is that? What is that? 2j minus 3. 2j. M is equal to 2j minus 3. This formula you have to remember, a standard formula. Okay, if this equation is going to be satisfied, if this equation is going to become satisfied, we are going to call it as a perfect frame. We are going to, M is stands for member. M is member. Okay,
ते
and J
member
is
काय
joint.
sir?
सांगतो एक मिनिट, जॉईंट मेंबर म्हणजे आता हे तुम्हाला दिसतं 1 to 2. म्हणजे आता इथं तुम्ही जे फक्त फर्स्ट इमेज कडे कॉन्सन्ट्रेट करा. फर्स्ट इमेज, फॉरगेट अबाउट सेकंड. 1 to 2. आता इथं तुम्हाला 1 2 3 दिसतंय बघा. परत एकदा 1 2 3 दिसतंय, पण एकाला सर्कल केलंय आणि एकाला सर्कल केलेलं नाही. ओके, आता मी हे 1 to 2 जर म्हटलं तर हा झाला माझा मेंबर. 1 to 2 हा झाला एक मेंबर. ओके, 2 to 3 हा झाला माझा दुसरा मेंबर आय एम. ओके, इथे instead of that, in short I will give, instead of that this, not that also, means sides of triangle, sides of triangle are called as member. ओके, साइड्स म्हणजे जे काही साइड्स आहेत या ट्रायंगलच्या ते झाले मेंबर इन शॉर्ट. आणि याला काय म्हणतो आपण, अपेक्स म्हणतो का? व्हॉट वी आर गोइंग टू कॉल इट एज? या पॉइंटला काय म्हणायचं? व्हॉट वी आर गोइंग टू कॉल इट एज? साइड्स अँड दिस इज व्हॉट?
Apex.
Vertex.
Apex.
Apex or vertex, whatever it may be, it is called as joint. It is called as joint. त्याला joint म्हटलं जातं. अलग लक्षात, apex or that. So here in this first image, this one is member. म्हणजे ज्याच्या भोवती सर्कल केलेला आहे तो एक मेंबर आहे, हा एक मेंबर आहे. आणि विदाउट सर्कल जे नंबर आहेत 1 2 3, these are the joints. So if we'll take example of first triangular frame, how many members are there and how many joints are there in first case?
3.
पहिल्या केस मध्ये
3 members and
3
3
3
joints.
if this equation is going to satisfy, if this equation is going to satisfy, then we are going to call it as perfect frame. Now just say, is it going to satisfy in here? So 3 is equal to 2j minus 3. So 3 is equal to 3. 3 into 2 6, 6 minus 3 3. So this first triangular frame will be the example of what? Which type of frame? Perfect frame. It will be the example of perfect frame. This is standard formula. So this you should know. In multiple choice question also it may ask. It may be asked. M is equal to 2j minus 3. M stands for what?
Member.
member
And J stands for
Joints.
joints.
joints. Okay, so perfect frame we have seen. Next. Have you understand difference between member and joint? Member कोणाला म्हणायचं आणि joint कोणाला म्हणायचं हे लक्षात आलं?
Yes sir.
Yes sir.
Okay, next. It may be observed that to increase one joint in a perfect frame, 2 more members are required. Hence, the following expression may be written as the relationship between number of joints J and the number of members. Okay, that is the explanation for that equation. Then, however, the equation used only necessary but not sufficient condition of perfect frame. For example, 2 frames shown in the figure have the same number of members and joints. The frame shown in the figure is a perfect frame since it can be retained its shape for a loading at any joint in the frame shown in the figure is not capable of retaining its shape if loaded at joint, hence necessary to sufficient condition of perfect frame is it should be retain its shape when load is applied. Means whatever equation we are going to use, it is not only a sufficient condition to identify the perfect frame. Actually, there are mainly three types that we will see: deficient, redundant, and perfect. So with this equation, so which I have given, which three are there? Perfect. Okay, one is perfect, then another one is deficient. Deficient means members are not sufficient to take load. Deficient, and another one is redundant. Redundant. What will be the spelling? Redundant. Just check. Redundant. That will
D-A-N-T, sir.
D
A-N-T, last.
D-A-N-T, sir. Redundant. That we will see. Perfect, deficient, and redundant. These are the types of frame sorters. What is we have just seen perfect. If number of members are sufficient to take load, means number of member equal to number of joints. Perfect. Deficient we will see now. Deficient and redundant. So don't worry. Some explanation is given. Something. Type. Sorry. Maybe here. A frame is said to be deficient. A frame is said to be deficient if the number of members it in are less than that required for the perfect frame. These frames cannot retain their shape when loaded. Deficient means not sufficient, or we can say, in other words, less. In other words, we can say it as a less. Okay, a frame is said to be a deficient if the number of members in it are less than the required for the perfect frame. These frames cannot retain their shape. So we are going to call it as a deficient. Means what that equation will become? This side members are less than joint 2j minus 2. In this case, we are going to call it deficient. Then a frame is said to be redundant if the number of members in it are more than the required for the perfect frame. Such frames cannot be analyzed by using the equations of equilibrium. Only thus the redundant frame is statistically indeterminate frame. So if number of members are more than the number of joints, then we are going to call it as a redundant frame. So such frame cannot be solved statistically. So we are going to call it as an indeterminate frame. So let us see for this equation. So who will tell me number of members and number of joints? M is equal to and J is equal to for this figure. How many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 members are there. Joint now. 1, 2, 3.
6.
6.
Okay, 6. Just check. Put in equation and just check what is happening. Or members are. We have said opposite. M is equal to will come 9.
Equal येते sir.
Equal?
Yes sir.
Okay.
Yes
So I
sir.
think this is example of, I think,
Perfect.
frame. Perfect frame. Okay. So we should not relate in unnecessary. We will check. Let us go for this. M is equal to how much? We will see how that structure is. M and J. Calculate for this. How many members are there in this? 4, 6, 7, 8, 9. Again 9. How many members are there?
9.
9.
And how many joints are there?
6.
6 joints. Now put the
Same
equation.
stated, sir.
Same. This one is also perfect. So here there is no joint. Here there is no joint at the center or at the middle. There is no joint. You keep in mind, there is no joint there. So again, this one is also perfect frame. So I will write this is perfect frame. This one is also perfect frame. Okay. Next, here for this frame, m is equal to how much, and j is equal to how much for this third figure. 4, 4. Both will be 4.
Yes, sir.
Yes, sir.
Okay. Put in equation. M is equal to 2j minus 3.
Less than येते sir.
Less than means this m is less than 2j minus 3. M is less than 2j minus 3. So if it is less, number of members are not sufficient to take load, then what type of it will come?
Deficient frame.
Deficient frame. We are going to call it as a deficient frame. Okay, deficient frame. So here it is a perfect frame. Perfect. And then here also perfect. Next, for this now tell me this m is equal to how much and j is equal to how much. How many members are there? Just count in if you are able to see the figure. 1, 2, 3.
11.
11.
11. Sure, I have not counted. I am believing on you. 11. Okay, joint. 3, 3, 6. I think 6.
6.
Okay, just check. Put in equation. What is happening?
Greater than.
Greater
Greater
than.
than 2j. Greater than 2j minus 3.
Yes, sir.
Yes, sir.
So what will be the frame type of frame?
Redundant.
Redundant.
Redundant. Redundant. Redundant frame. So how many types of frames are there?
3.
3.
2 or 3? How many are there?
3.
3.
Which are they? Which are they?
Perfect, deficient, and redundant.
Perfect, deficient, and redundant. What is that? To whom we should call it as a perfect frame? Or on which basis we are deciding? Or what is the equation on which we are deciding type of frame? कुठली इक्वेशन आहे की ज्याच्यावर आपण ठरवतो?
M is equal to 2j minus 3.
M is equal to 2j minus 3. What for M stands for?
Member.
M stands
Member.
for what?
Member.
Number of.
M stands for number of members. Not member only, number of members. And what is J stands for?
Number of joints.
Number of
Number
joints.
of joints.
Number of joints. So for the perfect frame, what is happening? Or to whom we should call it as a perfect frame?
Number of
equation
member
will
is
be-
equals to number of joints.
Number of members is equal to number of joints. Or in technical
sir.
word we can say. It may not be the case.
Yes, sir. M is equal to 2j minus
M is
3
equals to
satisfies
2j
झालं तर
minus
बस.
But we cannot say no if number of member equal to number of joint. हे म्हणणं चुकीचं आहे. It may not be. What I feel, you can check. Suppose 3 is there. Actually, we should take some examples so that we will understand. We cannot say directly if number of members are equal
Yes,
to
sir.
number of. We cannot. So in other words, so what we can say, number of members are sufficient to take load. Sufficient member जर असतील लोड घेण्यासाठी तर त्याला परफेक्ट फ्रेम म्हटलं जातं. Actually, theoretically we can say theoretically, but how to decide? Decide कसं करायचं तर त्या इक्वेशन वरून m is equal to 2j minus 3. If this equation is going to become satisfied, perfect. If number of members are less or we can say not sufficient to take load, then it is called as deficient frame. Then we are going to call it as a deficient frame. And if number of members are more in the frame, if number of are more than requirement, it extra असते थोडे redundant मध्ये. In short, it is extra. More members are there, extra more we can say. Such frame is called as indeterminate frame, and indeterminate frame is statistically indeterminate. We cannot solve that frame. So in multiple choice question may be asked us, which of the following frame is indeterminate? कुठली फ्रेम ही indeterminate असते. So what should be your answer in that case?
Redundant.
Let's say redundant frame is a statistically indeterminate frame, कारण त्याच्यामध्ये एक्स्ट्रा मेंबर असतात. We cannot solve, we cannot analyze. Okay, for multiple choice question, or on which equation or on which basis we are deciding the type of frame. So m is equal to 2j minus 3. So that also you have to remember. Okay, then assumptions in analysis. Are you with me? समजतंय काय चाललंय? Or whether we are going fast?
Yes, sir.
Okay. Just a theoretical part. Few very less part is there. Very small chapter. This one is very small chapter. Assumptions in the analysis of pin joint trusses means once we are going to analyze, we should go for certain assumptions. काही गोष्टी आपल्याला मानायच्या आहेत. Or we have to assume something here. Once we are going to solve problems of analysis, which are they? Just check. The following assumptions are made in the analysis of pin joint trusses. Number one, the ends of the members are pin connected or hinged. काय म्हटलंय इथं? The ends of the members are pin connected or hinged. How many reactions are coming at the hinge?
2.
What is the example of hinged joint? I have told in case of beam. Example कोणाला आठवतंय का सांगा?
Door.
Yes, somebody has told correct. What is that?
Door.
Door.
Sir.
It can rotate. It can rotate, but it can't move. दरवाजा हा फक्त फिरतो, बाहेर येत नाही तिथून. That's why it is called as something like hinged joint. The loads are only at the joint. म्हणजे एक assumption आहे, तुम्ही in between load देऊ शकत नाही. If you want to apply load, it should be at joint only. You should not, or it cannot be applied. The load cannot be applied on in between. That is one. Next one, self weight of the member is negligible. There may be some weight. प्रत्येक मेंबरचं काहीतरी वेट असणार आहे, पण ते आपण निग्लेक्ट करणार आहोत. So self weight of the member will be negligible. Then members are having either uniform cross section throughout, or if they are having varying cross section, the centroid is located along the same longitudinal line. Forget about second line. Here what we are going to assume? Members are having either uniform cross section throughout. एकतर त्यांचा क्रॉस सेक्शन हा युनिफॉर्मच असला पाहिजे, आपण असंच मानणार आहोत. Unless and until mentioned, मेन्शनच केलं नसेल तर we are going to assume their cross section is uniform. These are the 4 assumptions while solving the problems on pin joint trusses. Okay, are you with me? Only 4 assumptions are there. Ends are hinged or pin connected. Then loads are at only joint. Self weight is negligible, and members are either having cross section, uniform cross section. Are you with me?
Yes, sir.
Yes.
Nature of force. फोर्सचं नेचर कसं असतो?
Positive or negative.
Okay, good. But till now we were considering either positive or negative. Okay, But in this chapter, it's a good thing you have given by either positive or negative. So, irrespective of x direction and y direction, it was the nature. But here some different words will become. That is tension. Either here we are going to say member under tension. एकतर member तो tension असेल किंवा compressive or compression. These are the two natures of forces. Here we are going to do these two natures of forces. Which are they? The members of pin joint frames are subjected to either tensile or compressive force. Positive, negative, whatever you have told, it is correct. But due to that positive and negative forces, that member will be subjected either in tensile nature or compressive nature. How we will see? A truss ABCD loaded at joint E as shown in figure. तर याला कशाला म्हणायचं टेन्शन आणि कोणाला म्हणायचं कॉम्प्रेशन? If so here it is also given. So you consider here and try to analyze to which force we are going to call it as a compression and for which force we are going to call it as a tension. Just observe, I have made 4 dots here and now from this just check करता येते का बघा बरं डेफिनेशन तुम्हाला. टेन्शन कोणाला म्हणायचं आणि कॉम्प्रेशन कोणाला म्हणायचं? To whom we should call compressive force or compression force and to whom we should call tension force.
The force which act opposite of each other is called compressive force.
Both दोन्ही पण opposite आहेत की. Both are
Attracting.
opposite. Both are
Attracting.
opposite, no?
Towards each other and towards each other. Tension.
Towards each other. थोडस बघा हे कसं आहे मी फिगर दाखवतो तुम्हाला थोडं कन्फ्युजन होईल. हे असं आहे का, हे असं आहे, हे असं आहे. इकडे फर्स्ट कॉम्प्रेशनचं आणि टेन्शनचं कसं आहे? टेन्शनचं असं आहे. म्हणजे फरक काय आहे का, विशेष काय आहे का? दोन्ही सेमच आहे जर मी बाहेर काढले फोर्सेस याच्यामधून तर. So here we have to take reference of joint. One clue I will give here. तुम्ही with respect to joint सांगा आता कॉम्प्रेसिव्ह कोणाला म्हणायचं आणि टेन्शन कोणाला म्हणायचं. मी जॉईंट काढलेत बघा, लाल पॉइंटने दाखवलेत ते, रेड कलर्ड पॉइंट आहे शोन. नाउ यू कॅन टेल with respect to joint you should tell the nature.
The force which directed towards the joint is called a compression and away from the joint is called a tension.
Yes, very good, that only I want. The force if it is going away from the joint, away, then it is called as tension, and if it is going towards, then it is called as compression. म्हणजे एखाद्या मेंबर मधलं फोर्स हे if it is something like this, tension away from the joint, पण हे जॉइंट पासून आहे लक्षात ठेवा. From the joint, away from the joint tension, towards the joint compression. Whether it is satisfying in figure मध्ये satisfy होत आहे का away from the joint and towards the joint?
Yes, sir.
Yes.
That is called as tension and compression. Okay. Further, this it is there. Methods of analysis that we will see in next lecture. So what we have studied today, have you understood this? काय काय शिकलो आपण, बऱ्याचशा गोष्टी आपण आज शिकलो. ट्रस बद्दल, व्हॉट इज ट्रस, तिथून चालू केला आपण. ट्रस म्हणजे काय? ओके, जस्ट आय विल रिकॅप. What is truss? From that point we have started. Truss is a collection of members, and to analyze the truss means to finalize the forces into it. Okay, so there are two methods we are going to study. One is method of joint, method of section. Okay, so why truss is used? Why the members in the truss is used? To distribute and transfer the force. Okay, then we have seen what is truss actually. Okay, so that introduction. So how it is? So there are two types of truss. Which are they? Plain truss we can say, or plain frame and space frame. Okay. And depending upon number of joints and number of members, three types are there. Which are they? Perfect, deficient, and redundant. Perfect, deficient, and redundant. So one equation you can use: m is equal to 2j minus 3. M is number of members, j is number of joints in the frame. So if that equation is going to satisfy, we are going to call it as perfect frame. If number of members are not sufficient to take load, if members are less, deficient. If members unnecessarily extra members are there in the frame, redundant frame. Then assumptions, we have seen assumptions. Okay, and after that, nature of forces. So either force in the truss, either force in the truss, either it will be tension or compression. And just now we have seen to whom we should call it as a tension and to whom we should call it as a compression. Okay, to whom we should call it a tension force in the truss. कुणाला म्हणायचं? कुणाला म्हणायचं टेन्शन फोर्स आणि कॉम्प्रेशन?
Which force are goes away from the joint?
The force which is acting away from the joint, tension, and towards the joint, compression. So that
Sir,
will be
आपण जनरली कॉम्प्रेशन म्हणजे असं एकमेकांकडे येणारे फोर्स, तर इथं वे का असेल असं आहे का?
नाही अवे म्हणता येणार नाही. इथं आपण रेफरन्स हा जॉईंट घेतलाय. तुमचं म्हणणं पण बरोबर आहे. कॉम्प्रेशन म्हणजे असं एकमेकाकडे पाहिजे. पण आपण विथ रिस्पेक्ट टू, मी त्याच्यासाठी म्हणलं की विथ रिस्पेक्ट टू कशाबद्दल बोलतोय आपण जॉईंटच्या रिलेट करतोय. जॉईंटच्या एखादा फोर्स हा कोणाला रिलेट करतोय त्याचं नेचर जॉईंटला. म्हणून कॉम्प्रेशन मध्ये काय असते की ते जॉईंट कडे जातो. म्हणजे जॉईंट आणि फोर्स तुमच्या भाषेमध्ये, जसे की तुम्ही म्हणता दोन फोर्सेस जर एकामेकाकडे चालले तर कॉम्प्रेशन. पण इथं आपण दोन फोर्सेस रिलेट करत नाहीत. एक जॉईंट आणि एक फोर्स. लक्षात येते का बघा थोडं. तुम्ही एक जॉईंट घेतलाय आणि त्याच्याकडे जर फोर्स चालला तर त्याला कॉम्प्रेशन म्हणणार. आणि एक जॉईंट तुम्ही पकडलाय आणि त्या जॉईंट पासून जर बाजूला चालला, अवे चालला, तर त्याला टेन्शन म्हणणार. सोप्यात
हा, म्हणजे जॉईंट शी रिलेटेड घ्यायचंय म्हटलं बरोबर आहे.
जॉईंट वी आर गोइंग टू टेक रिलेटेड टू जॉईंट. हे थोडं तुम्ही जर जास्त विचार केला तर जास्त कन्फ्युज होत जातं. त्याच्यासाठी मी थोडक्यात सांगितलं की हे रिलेटेड टू जॉईंट आहे. जॉईंट कडे चालला, टुवर्ड्स द जॉईंट कॉम्प्रेशन, अवे फ्रॉम द जॉईंट टेन्शन. एवढंच लक्षात ठेवा. हे कन्फ्युजन होतं पुढे, नंतर जाऊन कळत नाही की कॉम्प्रेशन कोणाला म्हणायचं आणि टेन्शन कोणाला म्हणायचं. त्याच्यासाठी इन शॉर्ट आय हॅव टोल्ड. So with this we will stop today. Tomorrow we are going to solve the problem on this. Okay. Anyone is having problem? कोणाला काय प्रॉब्लेम आहे का? नसेल तर whose next lecture is? I will take attendance meanwhile. Roll number 3. Roll number 3. I will write here attendance. 3 absent. 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 13, 14, 15, 16, 17, 18, 19. Roll number 19. 20, 21, 2, 3, 4, 5. 25. Who is 25? 27. 35. 39. Horrible situation. 41, 42, 43, 45. Okay, shall we stop for today? Thank you very much.